All right, so we're going to make a video for absolute value functions, and I am talking quietly because there's a class in my room. Also, I pulled up Desmos and I did a split screen because I think that might help with some of these. So hopefully you guys remember that the parent function of absolute value is y equals the absolute value of x, and it looks like this, which makes sense because when you take the absolute value, it's all positive. So it's basically a line, but this half is flipped up because it's positive. So if we put some numbers in here, for x, we can find the y by taking the absolute value. So positives all the way, and those are our coordinates. All right, domain are all the x's. So we're going to start over here, and we first see right there with an arrow, and we keep seeing it, and we keep seeing it, and we keep seeing it, and that's where it ends. So from negative infinity to infinity. In interval notation, it looks like that. And you can also write it as set notation if you want to. All right, for range though, we're looking at the y values. It starts here, but with a point, and we keep seeing it, and it ends with arrows. This point is located at 0, and this goes to infinity. So the range is negative 0 to infinity, or 0 is less than or equal to x is less than infinity. The x-intercepts, there's just one right there at 0, 0. There's one y-intercept at 0, 0. And as far as end behavior goes, as x is approaching negative infinity, this is going up. Y is increasing. So as x approaches negative infinity, y is approaching infinity. And as x is approaching infinity, y is also approaching infinity. All right? There are no asymptotes for the parent function absolute value. We actually do have a turning point here. We don't have a maximum and we don't have a minimum. Well, we do have a minimum. No max, but the minimum is 0, 0. And if you put that on here, it kind of helps to see it better. This is the x-axis. So from negative infinity to 0, this function is decreasing. But at 0, 0, it turns and it becomes increasing. So it's decreasing from negative infinity all the way to 0. And 0 is included. Oops, I flipped those. I'm going to change this to decreasing. And it's increasing from 0 to positive infinity. At no point is it just flat across, so there are no constant intervals. Keep in mind that these are manipulated by adding numbers and stuff around it. So if we put a 3 in front, it's going to be 3 times steeper. So this is going to be 3 times steeper. X plus 2 would move it 2 spaces to the left. And if we subtract 2, that's going to be 2 spaces down. If we put a negative here, it's going to be upside down. So if we wanted to graph this one, we're going to move this point 2 spaces to the left and 2 spaces down. It's going to be 3 times steeper. And you can kind of do that by plugging in numbers, but I'm just going to make it skinnier, and it's going upside down. So that's kind of an example of how that can be transformed. All right, I'm not going to use Desmos for that one because that one's pretty clear. Let's look at the next one. All right, the next one is the exponential function. Often it's written like this, but this doesn't have to be that number. It can be any number base. So for example, if we were going to use 2, -2, -1, 0, 1, and 2. If we were going to use 2, then we're substituting the 2 in here. Remember that a negative exponent means it flips. So if we have 2 to the -2, it's really 1 over 2 squared. So that would be 1/4. 2 to the -1 would be 1/2. 2 to the 0 is 1. Anything to the 0 power is 1. And then following that way. Okay, so you can see how that kind of translates into this graph where it's getting really close to the x-axis and then it takes off really fast. These numbers are going to get, those numbers are going to get big fast. If you think about the coronavirus graphs, you can kind of picture what we're talking about. So I'm going to stick this over here. Y equals e to the x. All right, so you can see how that looks. And I'll show you with the 2. All right, so there you go. We're going to kind of look at that. The domain is from -infinity, looking here, and it keeps going to here, so -infinity to infinity. The range starts here, which is really kind of 0, but it's not going to hit 0, and it keeps going. So we're going to use a parenthesis for that 0 instead of a bracket, or instead of a bracket because it doesn't include 0. There are no x-intercepts, but the y-intercept, which is the important point here, is at 0, 1. As far as end behavior goes, this little guy, as x is approaching infinity, y is approaching 0. It's not going to hit 0, but it's approaching 0. And as x is approaching positive infinity, y is approaching infinity. There is no vertical asymptote, but there is a horizontal asymptote at x, or at y equals 0. Right here. It's never going to hit there. Instead of calling it a turning point, I called it a key point because when you're moving this function around, that's kind of where you're moving it. The key point is that 0, 1 point. That's going to be an easy one to kind of move around. Increasing and decreasing, it's constantly increasing. So it's increasing from -infinity to infinity, and it is never decreasing. And it's also never constant. It's going to look pretty close to constant over here, but it's not. So if you look over at the Desmos side, how we can kind of manipulate this graph. If we add 2 to the x, we can see that the y-intercept moved. Or if we add 2 here, I thought I put it on the x, it's going to move that point up 2 spaces from 1 to 3. If we add 2 to the x, you can see it moved the whole thing backwards 2 spaces. So that space that was here at 3 is now, or when it was at 0, is now over here at -2. If we put a negative in front, it flips upside down. So it works exactly the same as all of the other functions, but it's easier to see on there than if I explain it. All right, and the last one is its inverse, which is the logarithmic function. I'm going to go with the natural log here over on Desmos. So y equals ln x. But it could also be written as y equals log to the little base here and x. Either way. They're slightly different. I'll kind of show you. There we go. I was filling in the chart. I'm just going to do it this way. It's going to be easier. Okay, so this is the graph of the natural log. It's the inverse of the exponential function. And I'm going to pick some points here. You're going to see that these answers are kind of weird. ln negative 2 is undefined. ln negative 1 is undefined, which makes sense because you can see that there are no points over here. There's a vertical asymptote, and we can figure that or write that here at x equals 0. No horizontal asymptote. So that's why we have nothing there. 0 is also undefined because we never reach 0. That's where the asymptote is. If we put in a 1, it equals 0. So you can see that's that important point right here, which we'll call the key point, is 1, 0, which, as you can see, is the inverse of the other one. And 2 is going to be some crazy fraction or decimal, 0.693. And it's just going to keep steadily getting bigger from there. Okay. The domain begins here and goes all the way to here, but 0 is not included, so parentheses 0 to infinity. The range starts here and goes all the way to here. Arrows on both ends mean negative infinity to infinity. There is no the x-intercept is at 1, 0, but there's no y-intercept. All right, we already did our turning point, which is really more of a key point. That's the point you're going to keep your eye on. And from here, from 0 all the way, it's increasing. At no point is x or y getting smaller. So it's increasing from 0, but not including 0, to infinity, and decreasing none. There's no space that it's constant. All right, so back over here to our parent function. We'll kind of look at how things affect it. If we put a 5 in front, it's going to get wider, right? If we put a 1/2, it's going to get a little squished. If we put the x in parentheses and subtract from it, going to move 5 spaces to the right. You can see we went from 1, 0 now to 5, or 6, 0. We added 5. If we want to move it down, subtract after that. If you want to move it up, add. Same controls as all of the other ones. I hope that you have a fabulous day.